All right, two additional tools that I want to touch on just briefly are the bitmeter and the K system. And the bitmeter is normally found floated over in the left-hand side of the user interface here. Pops out when you need it. Use these things only rarely, and when playback is started here, what this is showing you, let me float this on its own, is how many bits are being used. The green squares indicate a bit in use and the black ones are available. The inner two columns are instant and the outer two columns are sort of a recent history trend. And you have a red overload indicator at the top and then a below and interpolation at the bottom. And let me see if I can get this to overload just to see all the lights come on. Okay, so what the overload function is telling you there is that there are no more zeros and ones left to encode with, so everything else is going to be scrapped and you'll get digital distortion, which is horrible. The interpolation lights and the below lights are telling you there's bits beyond 24 bits that are either being used or interpolated between. And that's almost always going to be the case because the internal engine in WaveLab is a 32-bit floating point engine, which means even if you bring 8-bit material in, it's immediately changed to 32-bit as soon as you begin working on it. The only time you'd ever see 16 or 8 displayed here is if you brought a piece of audio in at that resolution, you had your master fader set to absolute 0. So shift and double click and they'll go to 0. And then no processing applied whatsoever. Then you would see 16 bits reflected there. And I guess the other thing is that, if you had maybe a wonky plug-in that was pulling your whole system down to 16 bits, you might see that here. And that's really about the only time you ever use this as some form of troubleshooting. So there's a lot out there written about bit meters. If you find yourself in a situation where you need one, it'll be for a very specific application beyond the scope of these videos. The primary point here is there is a bit meter, and that's where it is. Now, of a little more practical application is the K system calibration stuff. And if we open the settings again on our level meter, in the center here we've got the VU meter loudness scale, and we've got 4 options: standard and these 3 K systems. And remember, on our level meter, the outer 2 bars are instantaneous. The inner 2 are the VU that simulate the needle ballistics of a traditional meter. And the K system was developed by a guy named Bob Katz. He's a Grammy-winning engineer and audio mastering guru. And the whole idea with the K system is to move our target from digital 0 or digital max, sometimes called digital hot, back down the scale a little bit. And by resetting 0 further off your maximum, you'll mix with more headroom and you'll end up with better sounding mixes, even if they're not necessarily the loudest mix. There's this perception that louder is always better, and a lot of research says that's actually not the case. But in any case, the K system has become widely adopted, and a lot of people are using it for different applications, and it's very effective. And if you want to use it, the only catch is you need to use it correctly. So I'm going to set the meter back up to standard. And you'll see the 0 point jumps over the right-hand side, and we very quickly move to 12, and you'll see it jump down. And then we'll set all the way to 20, and it jumps down much further, down in here somewhere. And the 3 systems are for music and dynamic music and broadcasting. So K20, which moves the 0 point the furthest off maximum, was designed with the idea of classical music primarily, but anything with a really wide dynamic range. The K14 system is optimized for pop or rock music, and K12 is designed for broadcasters. And just to show you something, if we set the K12 system up here, it moves the 0 point to this area. If we jump over to that loudness meter, you will see that the 0 point is almost in exactly the same spot. And of course, this 0 point is defaulted to the R128 standard, which is the loudness requirement for broadcasters in Europe. And if we come back over here, the K12 broadcast K system puts the 0 point in almost exactly the same place. And it's really, I think that's kind of telling. It's sort of 2 ways to solve the same problem or to optimize the same type of material. So the idea here is if you want to set yourself up for success mixing music, you'd select the K14 system. And again, we're just talking about the inner meters here. And The other two things you need to do are calibrate the output of WaveLab and the actual monitoring volume in your listening environment. And the way you do that would be to generate a pink noise signal, which we can do with the tools here. We go to the signal generator, select pink noise as your waveform, and then come over and set your level at 0. And set this to 20 seconds and hit generate. And it's going to create a pink noise waveform. And for some reason, we got that in just the one channel, but no problem. I'm going to come back here to edit, select all, limit myself to the left channel only. Sorry, the right channel only. Hit Control C for copy, and then select left channel only and paste. Now we've got it on both sides. Not sure why I only did the one, but this is going to sound like static. Take a listen. Okay, so the first step is after you have your pink noise waveform generated, we're going to move the master faders over here until the inner, these slow responding meters, are hovering right around 0. Okay, that's pretty close. And the 0 point is the switch in those center bars from blue to yellow. Play just a moment or two more of that. Okay, so you can see that that's hovering right around the 0 point. With that output established for WaveLab, you then need to actually go get a physical sound pressure level, or SPL meter, a physical level meter for your monitoring environment, and then sit at the listening position and play that back so that it's metering 0, and you want 86 dB in the room at your listening position. 86 if you're doing both speakers at once. We're assuming stereo for all of this. If you're doing a single channel, it's 83 decibel per channel. But sit at your listening position with the meter, play that back so it's reading 0 on the screen, and then you want to go to your speakers or your amplifier, whatever it is, and tweak that until you're getting 86 at the listening position. And then you're set up for the K system for music, and what it's going to show you and what it's going to sound like is going to be calibrated so that it matches with anybody else that you're interacting with. So not a requirement, but a recommendation. And the only other thing to add to that is if you change K systems, if you decide, well, today we're doing a piece of classical music, so we'll set this at 20, the 0 point moves, you need to re-execute that same procedure, because 0 on the K meter should always equal 86 decibels at the listening position. There is one other technical aspect to consider with loudness, because I know somebody is watching this and saying, well, Bob Katz might want a quieter mix with more musicality, or the European broadcasters may be insisting on it, but darn it, I want the loudest mix possible. I'm going to put a brick wall limiter in here and shove the throttles all the way up. And Lord knows there are certainly a lot of people doing that. There's an additional technical problem with that beyond the artistic considerations and so on, and that is that full-scale digital output translates to about +10 in the volume unit, or VU, world. And back when VU was the only standard that we had, your peak limits were about +3, maybe +6, depending on the tape and the content and program. And beyond +6 was just way too hot, distortion hot. And the +10 level that you're going to get out of this system is way beyond that. And so if you're using any external equipment, any hardware equipment for signal processing, it's going to expect no more than a +6 dB, 6 VU signal. +10 is going to just overblow it. And even if you're using a digital plugin, some of these high-end plugins like the Waves stuff that so painfully and accurately represents the real-world stuff for limiters and reverbs and all kinds of stuff, when they build those, they do them to emulate on the component level. So they're modeling each resistor and each tube and so forth. That stuff is also expecting a signal no hotter than about +3 or +6. If you hit it with something that's the equivalent of +10, again, it's just going to distort all over the place. And if you poke around on the forums and stuff, you'll see that there are people out there that are paying a fortune for external hardware or these really high-end plugins, and then they're hitting them with one of these maximized mixes, and it's just sounding terrible, and everybody's upset about why is that? Well, you're feeding it a lot more signal than it was ever designed to take, and it's just not going to work. So in addition to staying away from digital maximum for artistic reasons and so forth, there are some pretty hardcore technical arguments for mixing at a slightly lower level, which is why, again, if you try these the K-system metering setups that are going to move your target back off the red line, you will end up with a mix that's more musical, and it's also going to keep you out of technical trouble as well. So just consider that, just more tools to use. And with that, we will leave the subject of metering and begin looking at how to apply them as we move into editing.